Hello class, we're back again. Today we're going to be looking at Unit 1, Lesson 2, the properties of real numbers. So let's look at our learning targets for today. We have two. First of all, students will be able to distinguish between the properties given an example or description. And secondly, students will be able to provide counterexamples for statements about properties that are incorrect. So what are properties of real numbers? In math, properties are statements that are true for any number. These properties justify steps when simplifying expressions and solving equations. So what properties will we be discussing today? There are several, so get ready to take some notes and let's get started. The first one is the commutative property. It's of addition and multiplication. The main idea, the order of the values does not matter, or it will not change your answer. So we have some examples here. So for addition, we're looking at things like a plus b equals b plus a, or 7 plus 5 is the same thing as 5 plus 7. And for multiplication, x times y is the same thing as y times x. 6 times 7 is the same thing as 7 times 6. The next property, the associative property of addition and multiplication. The main idea, grouping of values does not matter. When you see grouping, I want you to think about parentheses. Our example for addition, a plus b in parentheses plus c is the same thing as a plus parentheses b plus c. So we have 7 plus 3 in parentheses plus 2 is the same thing as 7 plus parentheses 3 plus 2. For multiplication, a times b, that quantity times c, is the same thing as a times quantity b times c. So 7 times 2 in parentheses times 6 will give you the same answer as 7 times parentheses 2 times 6. Next property is the identity property, also of addition and multiplication. Main idea, the values stay the same. So identity, what keeps the values the same. So for addition, that's 0. Any value plus 0 is going to give you that value back. So 5 plus 0 is 5. And then for multiplication, that value is 1. So 9 times 1 will give you 9, or a times 1 will give you a. Inverse property of addition and multiplication. Using the opposite to cancel a value. Okay, so we need to look at that a little carefully because we're using these terms. So a plus negative a is going to be 0. If you look at addition, so 5 plus negative 5. That's what we mean by the opposite. And multiplication, we're looking at the inverse. So we have a times 1 over a is equal to 1. Or in this case, 7 times 1 over 7 is also equal to 1. Property of 0, multiplying by 0 always equals 0. So we have several examples. 25 times 0 is 0. A times 0 is 0. Negative 1 over a times 0 is 0. Anything I multiply by 0 will always give me 0. Distributive property. The main idea, you multiply a value into an expression inside the parentheses. So for instance, a parentheses b plus c is going to be equal to a times b plus a times c. Looking at that with values, 3 times x plus 5 is going to give us 3x plus 15. If we do that with the negative 2 times quantity y minus x, that gives us negative 2y plus 2x. Now, those previous properties, you may have heard or seen something like those before, but I think these last three will be new. So this first new one is the reflexive property. So the reflexive property says a value is always equal to itself. So for instance, a equals a. All right. So 25 equals 25. 8y is equal to 8y. 3x squared is equal to 3x squared. The symmetric property. If a equals b, then b equals a. So for instance, if x equals 3, then 3 is going to be equal to x. If 6x is equal to 36, then 36 is equal to 6x. The transitive property. Now watch this. If a equals b, and B equals C, then A is going to equal C. So let's look at an example. If 4 plus 3 is equal to 7, and 7 is equal to the square root of 49, then 4 plus 3 equals the square root of 49. Okay? The last property, the closure property. Need to move this picture up so we can see it all. The main idea: a set is closed under an operation if the operation always produces an element of the same set. If an element outside the set is produced, then the operation is not closed. We're going to look at two examples. First of all, natural numbers are not closed under subtraction because 7 minus 9 equals -2, and -2 is not a natural number. Now, I want to key in on something here. This is one of the learning objectives. The second one, this is what we call a counterexample, because this is an example that proves that what you originally said is not true. Counter against example. It's against the example. So natural numbers are not closed under subtraction. And another example here said even numbers are closed under addition because 2 plus 4 equals 6, which is another even number. Any two even numbers will sum up to another even number. Now, in order to prove something, I need to show that it always works. But if I want to disprove something, I only need one example of where it doesn't work. So counterexamples, you'll see in some of the problems, they'll say, okay, say if this is true or false, and if it's false, give a counterexample. So they're saying, give us one case where that doesn't work. Okay? Now, so what we're going to do is we're going to stop the video here. You have lots of properties that you've been exposed to get those down. We'll start doing lots of practice to help you recognize and practice identifying those, and then some additional problems as well in the practice and the master check. All right, see you on the next video.